Hey guys, welcome to ANS Solver. Today we'll be doing the concept of the sum and multiples of normal variables, which is a subtopic in the chapter of linear combinations of random variables. Okay, this is a very important concept to understand. These are asked in many past paper examples, and questions. So you need to know this. So now we'll start with the concept of sum. Okay, sum means independent observations. Correct? So basically in the question, what they'll do is they'll give you a variable, let's say x, which let's say is normally distributed. Okay, and the mean is let's say mean 1, comma, the variance 1. Okay, because in normal distribution it's mean comma variance. And you'll have another variable which is y, okay, which is basically normally distributed, okay, with a mean 2, comma, the variance 2. Correct? This is what you'll basically have. Now, there can be two possibilities. They can ask you the distribution of x plus y. So even this will be normally distributed. And the mean of x plus y will basically be the mean 1 plus mean 2, comma, the variance will be the variance 1 plus the variance 2, which you have. Correct? So this thing here is the combined mean and this thing here is the combined variance. This is what you need to know. Correct? Now they can even ask you another possibility. They can ask you the distribution of x minus y, which is basically normally distributed. Correct? This will be basically the mean 1 minus the mean 2 because the mean takes the same sign, comma, now the variance, which is important. This will be the variance 1, correct? But the sign in the middle will remain positive, correct? And then you'll have the variance 2, correct? Here the sign is positive because you know that variance can never, okay, be negative, correct? This is an important property which you need to know about variance, correct? Okay, so these are basically the distributions. Now, what they can do is, they can even tell you of the same variable and the same distribution, you'll have x1, x2, okay, and observations up to xn. And obviously, you know that this is basically of the same distribution, correct? This is what you know. So you know that x1, okay, will be normally distributed with a mean comma variance. Correct? X2 will also be normally distributed with a mean comma variance. And x3 will be distributed with, or not x3, you know this as xn. Correct? Will be distributed with the same mean comma variance. Correct? All of these will have the same distribution because they have the same variable, which is x. Correct? So in this case, okay, you need to know that the mean which you will have, okay, the mean which you will have will be n into the mean of the variable x. N will basically be the number, okay, of observations, correct? N will be the number of observations and the mean will be the mean of the variable x, correct, which will be provided in the question. So this is what you basically need to know, correct? Now they can even ask you the variance, which you need to know. The variance will be n into the variance provided, okay, of the question. So you need to know that the n here is the number of observation which you know, correct? But you even need to notice that this is not squared, correct? Because we had done this concept earlier also. Whenever there are independent observations, the n is not squared while calculating the variance, okay? And you know the n is basically the number of observations, correct? This is what you know. And this thing is basically the variance of the variable which will be provided, correct? So this is a very important concept to know. So basically in the question they'll use terms like randomly, independently, okay? Then you'll or independent observations, 5 independent apples, something like that they'll use. So you need to know that you don't need to square. Basically, n shouldn't be squared while calculating the variance. This is really critical to understand. Correct? Now, another concept which you'll have to know is basically the variance, sorry, the multiple. Not the variance, the multiple. Okay, this is a very important concept to understand. Okay, so in this case, let's say if I'm given, a variable x which is normally distributed with a mean comma the variance. Okay, and now they ask me, and it's basically a multiple question because they use terms like twice, thrice, times, basically a weight attached, which we even discussed in the previous videos. Correct? So basically you need to know that if I ask you now the distribution of ax plus b, where a and b are constant and x is the variable. Okay, so the mean will basically be a into, okay, I'll just write this in better handwriting. This will be a into the mean of x, correct, plus the b, which is the constant, comma, now the variance will basically be a square into the variance. This is what you basically need to know. So here the a is squared because it's a multiple, correct? Because it's basically a weight, it's kind of a weight, if it's twice, thrice, something like that, correct? And in the variance, no constants are allowed. So you first notice this thing is squared here, correct? And you notice that no constants, actually this is actually overall in the variance, there are no constants which are allowed. No constants in variance. So basically that's why b is not there, correct? We can't add it in variance, correct? Now another type they can ask you is, they can, let's say, give you x with a normal distribution, correct, which let's say has a mean 1, comma, a variance 1, and y can have a normal distribution with a mean 2, comma, the variance 2. Now they can ask you the distribution of ax plus by. A and b are constants, x and y are variables. So this will be normally distributed. Okay, the mean will be a into the mean 1 plus b into the mean 2, correct, comma, the variance now will be a square, okay, with the variance 1, correct, plus b square into the variance 2. You notice the square here because of the multiple, because it's a multiple. Now you will have ax minus by, which is normally distributed. Okay, now this will be a into the mean 1 minus b into the mean 2, comma, now here I'll again have a square with the variance 1, but now the sign in the middle will remain positive, correct? This you need to understand, this will remain positive, okay, because the variance can never be negative. So this is a very important thing which you need to know. Many students commit silly mistakes, okay, if they don't identify the question properly, and that can give you a wrong answer. So now this will be b square into the variance 2. So this is basically the distribution of ax plus by and ax minus by when it's a multiple question, correct? So the most important thing is in this full concept is identifying the question, knowing that whether it's a multiple or independent or a sum, correct? So now one small concept is left, okay, which we'll be covering that in the past paper example, which we are doing now. Okay, so basically these are basically all the concepts in this chapter, You need to understand these properly to implement them in the past paper examples. Okay, so this example is basically from 2018, May, June, paper 33. Okay, actually not paper 33, paper 73. My bad. Very sorry for the error. Yeah. So now the question is the times in minutes taken to complete two parts of a task are normally distributed with means. Okay, so this is the mean basically for part 1. Okay, this is the mean basically for part 2. And standard deviation, this is the standard deviation of part 1 and this is the standard deviation of part 2 respectively. Find the probability that the total time taken for the task is less than 8.5 minutes. First, write the information you have. You can write this as part 1, correct? And you can write this here as part 2. You can write the mean here, correct? And the variance here because you need mean variance. And you can write the mean here and you can write the variance here, correct? So for part 1, the mean you have is 4.5. The variance, in this case they have given the standard deviation which is 1.1. So the variance is the standard deviation square. So you can write this as 1.1 the whole square. And the mean of part 2 is 2.3 and the variance will be 0.7 the whole square. Correct? This is what you'll basically have. Now, what do you need? You need to calculate the probability that the total time taken for the task, the full task is basically the part 1 plus the part 2. Okay, this should be less than 8.5 minutes. This should be less than 8.5 minutes. So keep all the variables to one side, keep the constants on one side. Now, you need to know how do we calculate the probability. Okay, so please note the steps, it's important. First, you calculate the mean and the variance. So the mean you calculate of P1 plus P2. Basically all the variables, when you get all the variables to one side, you calculate the combined mean of that. So here the mean of P1 is 4.5 plus the mean of P2 is 2.3. So 4.5 plus 2.3 is 6.8. Now I'll have the variance, okay, of P1 plus P2, correct? The variance of P1 plus P2 will basically be 1.1 the whole square plus 0.7 the whole square. Basic substitution. So when I solve this on the calci, I get my answer as 1.7. Okay, so that was the first step to calculate the mean and variance. Now what you need to do is, you need to make a normal distribution graph, correct, which looks something like this. You know the mean which you have now is 6.8, correct, because now you'll only be looking at the combined mean and combined variance, correct. So you have this as 6.8. The value, okay, which is on the other side of the constant is 8.5. So you know 8.5 will lie somewhere here, correct. So I have 8.5 here. Now what you need to see is, you need the variables in this case to be less than the constant. So you basically need to calculate the probability of less than, correct, because that's the sign. So you basically need the area here, correct. So now you know in a normal distribution you need something called as the z value, correct. So the z value has the formula, okay, of the value of the constant minus the mean over the standard deviation. This is important to understand, correct. So now the z value will be equal to the constant which you have, in this case is 8.5, correct, that's the value, minus now the mean. The mean will be the combined variable, correct, because P1 plus P2, so basically the two variables combine together to form one variable. correct? Which gives basically the mean of 6.8. So I write 6.8 divided by the standard deviation. You have the combined variance. So the standard deviation is the square root of the variance. So now when you solve this on the calci, you get your z value as 1.3038. Correct? Now you need to understand the calculated steps. It's important. So basically on the calci, what you do is you click on mode. When you click on mode, you click on 3 where stat is written. Correct? Then you click on AC. Then you click on shift. Correct? Then you click on 1 and then you click on 5. Correct? This is what you need to know. I'll just write this as shift 1 and 5. If this is the first time you are hearing this process, okay, then please note it down, because this is basically to calculate the probability. Because once you have the z value, you need to calculate the probability. So once you click on mode 3 stat AC shift 1 5 on the calci, okay, you'll basically get on your display, you'll get options like 1p, 2q, correct, 3r and 4t. Knowing options 1 and 3 is the most important thing. Correct? 2 and 4 are not used that much. So option 1 means P. You click on P if you are calculating a less than value. Okay, sorry. Okay, when you are calculating a less than value. And you click on R when you are calculating a more than value. In this case, I am calculating less than 8.5. So I click on option 1. So when I do that, on the display I get P with a bracket here. In the bracket, I write the Z value, which is 1.3038. Now, when I write this and click on equal to, I get my answer, which is 0.904, which is basically the final answer and the probability. Correct? So this is basically how you solve a linear combination of random variable question. So first you need to form an equation. Okay, or before that, you need to write all your data here properly so that you're clear. Then you need to form an equation. Correct? When you form an equation, keep the variables on one side, keep the constant on one side. Now, because the variables here are combined, you can treat it as one variable. So you need to calculate a combination of the mean and a combination of the variance. After you calculate that, you need to see what you exactly need to calculate, what's the value, and if you need to calculate less than or more than, then you calculate the z value, you take the mean as the combined mean, you take the standard deviation as the square root of the combined variance which you have, correct? And then you calculate the z value, then you go to mode 3 stat AC shift 1 5. See if you need more than or less than. If you need less than, then you click on P, which is 1. If you need more than, you click on 3, which is R. Correct? Then you input the Z value and get your probability and write it to 3 significant figures. Correct? That's basically the full step. So now let's do the part 2, okay, of the same example. Okay, so this might be a little complex. Okay, but you can try it on your own because you're clear with the concept. So we need to find the probability that the time taken, okay, for the first part of the task is more than twice the time taken for the second part. Correct? So I need the probability that the part 1 is more than twice, which is 2, of part 2. The first thing which you need to highlight here, okay, is that the word twice has been used. This means this is a multiple question. Correct? Multiples. Okay, this 2 here is a weight and this is a multiple. This is what you need to know. Correct? Because that will affect the variance, correct? As we know the concept. So now the next step is get all the variables to one side. So I write this as part 1 minus 2 into part 2, which is more than 0. Now I treat the combination of variables as one variable. Now I need the mean. The mean will basically be the part 1 minus 2 into the part 2, which will be equal to the part 1. What is part 1 mean? We know it's 4.5 here, correct? And part 2 mean is 2.3. So I can write this simply as 4.5 minus 2 into 2.3, correct? Which will be equal to minus 0.1. And it's okay if you get negative mean, it's perfectly alright, correct? Mean can be positive or negative. Now comes the important thing, which is the variance, correct? The variance of part 1 minus part 2, or not part 1 minus part 2, part 1 minus 2 into part 2. Okay, so first what you do is write the variance of part 1 and part 2. The variance is 1.1 square and 0.7 the whole square. So you write 1.1 the whole square, correct? And you write 0.7, correct, the whole square. Now, what will be the sign in the middle first? That's important. Here we have a negative, but you know variance can never be negative, so the sign becomes positive. And now I told you the 2 which you have is a multiple. It's a weight. That means it will be squared. So you will basically have 2 square, which you need to understand. Correct? So now what you can do is you can write this as 1.1 the whole square plus 2 square into 0.7 the whole square, which is equal to 3.17. Correct? This is what you basically get. Now you make your normal distribution curve, correct, for your understanding. Here you have the combined mean as minus 0.1, correct, which you obtained here, correct. Now the constant in this case which you have is 0, correct. So 0 will basically lie somewhere here, correct. You'll have 0 here. Now what do you need? You need the variables to be more than 0. You need the probability to be more than 0. Correct? So more than 0 will basically be the part which is shaded here. Correct? So now what I do is I calculate the z value, which is important. The z value is basically the value minus the mean over the standard deviation. So the z value will be equal to, in this case, the value which I have is 0. So I write 0 minus the mean in this case I have is minus 0.1. So I write this as minus 0.1 combined mean. And the standard deviation will be the square root of the combined variance. So it's the square root of 3.17. Correct? So I'll have my z basically as 0.05616. Correct? This is what I'll basically get. Now, because you need more, okay, this is another step I think which I missed here probably. Okay, when you need less than, you write this as the phi of the z value. Correct? A basic step which you need to know. Correct? When you need less than, phi means less than. But in this case, you need more than the z value, correct? More than. So you write 1 minus the phi, correct, of 0.05616. Sorry, I missed this on the previous part. This is important to know, correct? So now, once you write this, what you do is, on the calci, okay, on the calci you click on mode. When you click on mode, you click on 3 where stat is written, correct. When you click on AC, then you click on shift, correct. Then you click on 1 and then on 5. When you do that, basically on the calci. Okay, on a display you get 1p, correct, 2q, 3r, and 4t, correct. So you click on option 1 when you need to calculate the less than values. You click on option 3 when you need to calculate more than values. In this case, I'm calculating more than, so I click on option 3. Like in the previous part, we had clicked on option 1 because that was less than. Here, this is more than. So I basically get R with a bracket here. And in the bracket, I input the Z value, which is 0.05616. And then when I click on equal to, I get my answer as 0.478, which is basically the final probability and your answer. Okay, so again to refer back, I'm very sorry I forgot the step here. This is really important, the 1 minus phi and phi. You might be knowing this from before also, that phi means less than and 1 minus phi is for more than. You just need to write it because there's one mark given to it. I'm sorry I forgot it in the first part. Okay, but this is very important to refer. Okay, so once you write that, then obviously you don't need to write all the calci steps which I wrote here. Correct, the part in blue, that was for your understanding. After the 1 minus phi, you can just directly write the probability. Correct, that's what you basically need. Okay, so with this we come to the end of the chapter of linear combination of random variables. Okay, so please practice the past paper examples because there are many various type of questions, okay, which they ask, correct, and you need to practice a lot for this chapter to get a good grip. Okay, so you can go to the topic wise questions, practice it totally properly, correct, and get a master of the chapter. And even if you get stuck, we provide past paper examples, correct, for each and every question, so you can refer to those, okay, and have your concepts clear. Okay, so thank you very much for watching.